All right, today we have a 2008 Mitsubishi Pajero. This has the turbo diesel 4M41 engine, and the complaint is there's loss of braking. So the client was driving home. She said that when she just pulled into her gate, she had this very loud beeping sound, and then she didn't know what that was. She didn't know where it was coming from. She said that there were no warnings on the dash. Then when she tried braking on the downhill descent to her house, which is down there, so you can see it's a downslope, she couldn't stop, and she went all the way and hit the bushes over there. And then she was towed back up here to the parking. Pretty scary. So she said she lost brakes. Now when I've come and I've put on the car, this is what you hear. So there's that beeping sound. It's very, very loud. I don't know if the camera is doing it justice. And when I start this car and I push on the brake, we do have brake, but we don't have any assisted braking. So there is braking, but no assisted braking. So she's lost the assisted braking. So what you have to do is you have to stand on the brakes really, really hard to get this thing to stop. Now, this is a warning to all of us who drive modern cars. The more the years go, the more manufacturers prioritize comfort over function. Cars now have prioritized comfort so much that when people lose assisted braking, they actually think they've lost brakes, because the braking function done by your foot is about 20% of what the actual pressure is. The rest is done by the car, especially systems like this which have hydraulic braking. So if you lose your assisted braking, you need to be prepared to really stand on your brakes hard, because you will be compensating for what the car does, which is like 70% plus your 30%. So that's what happened here. Now I have done a preliminary scan, and these are the codes that we've pulled. So we have accumulator pressure low, we have a motor open for too long, and we have a motor circuit. So those are our codes. Now this is the hydraulic braking system, and I had to do some homework on how it works. Let me first describe to you how it works, and then we can proceed with our troubleshooting. So on assisted hydraulic braking systems, they're called HBBs, which is hydraulic brake boosters. How you will know that it's hydraulic is you have this accumulator cylinder here. So it's the same concept as the one which was in the Land Cruiser 100 that I did on a previous video. What you have is an accumulator which has a high pressure gas in here, usually nitrogen. It's highly pressurized, and then you have a motor which sits under somewhere here. So the motor pumps up the fluid into the accumulator. The accumulator provides a backward force into the system and maintains a high amount of pressure. I don't know exactly what it is. I've forgotten. Maybe about 2 ampere. I don't know. It's not really important right now. What you just need to know is the electric motor will turn on, pressurize the system, and then the accumulator will provide the padded back pressure into the system. So at all times, the hydraulic system is pressurized. And then when you press the brake, you only compensate by very little to now actuate your calipers. These potentially then have, and then inside here you've got pressure sensors, 2 pressure sensors, one for the accumulator side and then the other one for the system side on the lines. If you lose pressure, your pressure switches either open or close, and that sends that signal to the brake ECU, and you get that buzz. That is not really a buzz, it's a beep. It's more of a beep. So when you hear that, it means you have lost pressure. The only time that comes on is when you have lost pressure. So, potential places of failure. 1, you can fail in your pressure sensors. 2, you can fail in your motor. And 3, you can fail on your accumulator. So your motor is pumping up, but your accumulator isn't providing enough back pressure to make sure the system comes up to pressure. So those are the 3 potential places of failure. Now, and of course, the 4th one is you have a hydraulic leak. Now, we don't have a leak in this system. As you can see here, we still have fluid inside the system. And when I press on the brake, it's quite firm. In fact, I've moved this car back and forth. And if you stand on the brakes, you actually can stop this car. So we do not have a leak. What we have is a failure to pressurize the system adequately. Now, let's go to our code setting criteria. Let's pull up one of the codes and see what it says, and then we'll go to the wiring diagram and pull up the wiring diagram for this. I'm interested to see our command for the motor so that we see whether the motor is turning on, and if so, if the motor is able to pressurize the system. Alright, let's look at one of the code setting criteria here. We're going to pick code 57, which is the accumulator system low pressure warning, switch malfunction, or accumulator pressure too low. So this is your schematic here, and it says here operation. The pressure switch for low pressure warning monitors brake fluid pressure inside the hydraulic brake booster HBB. When the brake fluid pressure decreases abnormally, the pressure switch for low pressure warning is turned off, and the brake fluid low pressure warning signal is output to the ASTC ECU. Diagnose test conditions. Diagnosis code number 57 is set if the brake fluid pressure decreases or the pressure switch for the low pressure warning off seizes up occurs. In this case, the ECU sounds the buzzer continuously to inform the trouble to the driver and protects the pump motor by activating the pump motor internally. These Japanese to English translations are sometimes hilarious. So what we know is the switch inside the system, which is this one, pressure switch for low pressure warning, when it goes off, is it off? Let's see. When the brake fluid pressure decreases abnormally, the pressure switch for low pressure is turned off. Okay, so this switch is normally on if pressure is good, and then it turns off when the pressure is low. Now, if you look at this, the ECU will send a voltage this side, which I think is 5 volts. And then when it is turned on, it drops this line down to 0. Okay, because this other side is a ground. So this side of the switch should be 0 if your pressure is good, and then it opens and turns off when the pressure is bad. So you should get around 5 volts from here. I'm assuming it's 5 volts. Now let's go to the wiring diagram, which is this one here, page 5 of the wiring diagram. You have the motor, which is controlled by motor relay 1 and 2 on this line, green, red, and there's another one, blue, red, and they're on 2 different connectors. The first one's on B107, the second one is on B108. And this is interesting. You have this for redundancy purposes. In case one relay fails, you never want to leave the driver without assisted braking. So this is just a backup fail-safe system. And then inside here, the motor is monitored on line 14 here, on the STC ECU to monitor the power input, and I am assuming also monitoring the current consumption of the motor. And then the motor is permanently connected to ground here. I don't know why it's passing through a resistor here. That's interesting. Anyway, so it's permanently grounded on B108 32 and B107 pin 7 over here. Now, is this really pin 32? These are many pins. Okay, so what we'll need to do is, let's take a voltage measurement on this green-red wire here, and we'll put a current clamp there as well. And then we are going to monitor this ground here on pin number 4, this orange wire. So over here we should have a ground at all times, and then here we should have power when the relays turn on. If we don't see anything here, we are going to monitor the current of this other one. So let's go to our motor and make our connections. All right, there are connections. Channel 1, we've got the relay 1 input. Channel 2, we have that ground monitoring from this hydraulic brake booster unit. And then channel 3, we're going to take the current consumption of the motor on relay 1. Remember, there are 2 relays, so if we don't see anything here, we won't get too excited. We're going to test on the second one. I think it's this one down here. So let's go and turn the car on and see what we have. Pico is running. Let's go and put on the ignition. That accumulator should start pumping up, and there's a relay here, and you will hear the relay. Listen to it. There's a relay on, and then it goes off. So we have voltage, we do not have any current. Interesting. Now the other thing, it looks like on the red we have a ground. Let's really test whether that is a ground. So I have my test light connected to battery positive. So if I touch the ground there, so let's touch this and see whether we have a ground. Now look at this. That is a very, very weak. In fact, that's not a ground at all. Because if you look at the scope, I'm able to pulse that up. And just for reference, look again what it looks like. This is what a good ground is, and this is what we have here. Barely anything. So right now we have an issue with our ground. Let me put the car off. Let's relocate to relay number 2 and do the same test. Alright, for my next test, I'm testing my monitor relay 2 line on B108, and that is the blue-red wire. And then I've relocated my channel B from this ground monitor to this ground monitor over here. There is a resistor here, so I could be interrupted by that resistor from measuring this ground completely. This one, I can see it is tethered directly to ground, so my test light should light up quite a bit here if I have a full ground. So current clamp and voltage here, and then we're going to monitor this. I'm already set up. Picoscope is running again. Let us now turn the ignition on. Ignition is on. Relays are pulsing on and off. I can hear them. Okay, there's a relay on. And now let's test our ground here. First, let's see our test light, make sure that we have a good connection to battery positive, which we do. And now let's touch this, and as you can see, that's bright. So this is a good ground, and we have power on both relays. We have a good ground. We do not have any motor action. Folks, this is a bad hydraulic motor. So we don't have an issue with our accumulator. Our accumulator lost pressure because the hydraulic motor could not keep up and pressurize that. So we have a bad hydraulic motor. Unfortunately, that is going to be a bit pricey. We're going to price out that for the client, see what he wants to do. But let's see, just like we did with the Land Cruiser, let's see if we can wake up this guy by giving it a few love taps. Okay, let me show you where the motor is. This motor is under the brake booster assembly. Let me just go down here and show you. And there it is. So what I'm going to do is I'm going to take and put my torch here. And I'm going to take a wrench and I'll come under here. If I can reach a nice angle. Yeah, there. So I'm going to bang on that motor, but I want to do that while the key is on, and we'll monitor the Pico and see if this thing happens to wake up. Let's see. So let's start the Pico. The Pico is running, and let's go put on the key. Key's on. Warning is on. And let's come here. Get our wrench and give it a few smackaroos here while watching the picoscope. Oh, I keep losing my voltage channel. Let me just put this nicely. All right, there we go. Now let me smack here. And there we go. So the motor is stuck, and now the motor is running. So now we have motor action, but that is not good for the motor still.
Let's write down. Let's write down.
So let's see if it will pressurize the system enough for that brake warning to go away. All right, so let me pause this and let us see what we have here. All right, so this is our motor. Oh, this doesn't look good at all. Yeah, that doesn't look good at all. This is garbage right here. Yeah, so this motor is not going to pressurize this system adequately. So we are done. We have a bad hydraulic motor. It is weak, it is internally not good, and it will not pressurize the accumulator. So this is done. Let's see how much this costs and let's price it out for the client. All right, here is the part required. This is the motor, and your part number is 4630A481, and this one costs roughly around $400 to $450 with 3 to 4 hour labor time for installation, and that'll take care of this problem. Well, that's it. 2008 Pajero with a bad hydraulic motor. All right, I'm back here a week later, and my client got the motor. That's your part number there, and this is the motor. This is the old one. Now guys, this part is very expensive. This was 84,000 shillings. So you need to be 84,000 shillings confident of your diagnosis. Are you? I am, and we'll see in a minute whether I'm right or wrong. So the only thing to watch out for is when you're taking this out, number one, do not use this type of wrench to break free your brake lines. You will strip your brake lines. You need to use a flare wrench and then use this after they've broken free to just ease them out. So that's one thing. Oh, there's my flare wrench right there. So this is the only thing you should use to crack open your brake lines. Otherwise you will damage them. These ones, for some reason, for these hydraulic units, they stick really hard. I think it's because of the amount of pressure that goes, so it slightly deforms the threads. So you need a line wrench. Number two, be very careful while removing your accumulator. This accumulator is just as expensive as this motor. You damage this accumulator, you are going to be in for a very expensive repair. So remove this carefully. You're supposed to use an accumulator wrench for it. I don't have one. I used that type of wrench, but I protected the housing with a cloth so that I don't dent or damage the housing, and as you can see, came out completely intact. And then number three, do not just leave brake fluid to go down your client's car. I see this a lot. Brake fluid will eat paint very quickly. Protect your client's investment. These are expensive cars. You want your client not to have liabilities of rusting after you do this job. So protect your brake lines. Protect your car with just a cloth. It doesn't take much to do this, but believe it or not, I don't see this being done here, even on dealers. And then of course we're going to clean all this up. These are seeds. There's a lot of vegetation where we are. Okay, so this one went well. About a 2-hour job. I normally recommend replacing this hose, but my client did not want to hear anything of it, so not my car, but it's still supple. I'm not too worried about it. It doesn't come with the motor. The bracket does come with the motor. I struggled removing the motor from here, but you just need to remove it from here because the new motor, as you can see, comes with a bracket. All right, let me put this together, put it back in the car. We're going to do a final test. All right, the work is done. Everything is in. Went very well. No complications. So I've hosed down this whole area. Very little brake fluid went on the body, but I've put a lot of water to soak it down and to remove it. So we're good to go there. Now we're going to start the car. Actually, not start the car. Just put the key on and this will start priming. Now do not be afraid of the buzzer. The buzzer will remain on until your accumulator primes up. Depending on the system, this may take about 10 to 20 cycles of the pump, so be patient. Once you hear the buzzer go off, you know it is done, and you'll also know that your pump is strong. Every time it pumps, this accumulator will kind of shake and you will see it react to the pressure that's coming into it. All right, enough talking. let's put on the key and let the system prime. Keys on. So it's priming. You can see it's shaking every time the pump goes on and off. Watch that. My buzzer is off now. That's a good sign. I can hear it change. Yes. Yes. That is done. So now the system is pressurized. This should have no problem. Buzzer is off. Motor is off. And now we'll just check the brake. Oh yes. And I can hear the hydraulic has come on just to compensate for what I'm doing. It's off. It's on again. Just as intended. So I'm going to start the car. And what is that? That's a different thing. The engine is doing something wild. The check engine light was on, and I did notice that it was on prior to me starting. That's a different thing altogether, but I do not like that. That sounds like diesel misfire. All right, but our work here is done. That's an engine thing, has nothing to do with the brakes. You can see the check engine light is on. I'm going to ask him if he wants a diagnosis on that. If he doesn't, my work here is done. If he does, maybe I'll bring you on for that one. But the brake is done. The AST is off. ASC. The switch on the dash here has kind of popped in. It's fallen inside. So we'll fish it out and put the ASC on, and that should be okay. But that's it. All done, and the new part has fixed it. And just a word, a lot of people put used hydraulic boosters in this thing. I will tell you why that's not a good idea. First of all, the price of this entire unit used is more expensive than the price of a new motor. Second thing is you're getting something that you don't know what state it's in. A lot of shops here do strange things to their parts. They change out accumulators and stuff. When you do this way, you know that one, you're putting in a new part. It's going to last you another 200, 300,000 kilometers. And second, you know that the accumulator you have is good because it's your original accumulator. Everything else remains yours. This is the best way to go. Do not be afraid of fixing it right. I know it's expensive, but this is the best way to go. All right. 2008 Pajero diesel. I've got a feeling we're coming back for that. But for now, another one for the books. Until next time.